In this video, we're going to learn how to solve a system with linear equation with 2 unknowns and 3 unknowns. So first, let's introduce some concepts. What is a system of linear equations? A system of linear equation consists of 2 or more linear equations. The solution to a system with 2 variables and 2 equations is any ordered pair that solve both linear equations. While the solution to any system with 3 variables and 3 equations is a triplet coordinate that satisfy the 3 linear equation upon substitution of the variables. Let's see the first example of a solution of a system. Determine if the point -3, 1 is a solution to the given system that consists of x minus y equal -4 and 2x plus 10y equal 4. To solve this, we need to plug in the coordinates of the point wherever I see x and y in my equations. Notice that in the two equations, we obtain a true statement. Therefore, the point -3, 1 produces a true statement in both equations. It is a solution. Another example. So we have a different system with the same point. Determine whether the given point is a solution to the following system. Again, we need to plug the coordinates of that point whenever I see x and y in my equations. Notice in the second equation, we obtain a false statement. Therefore, this point is not a solution to my system. Type of systems, we have 3 types. When 2 lines intersect, we obtain exactly one solution. It means the system is consistent and independent. If they are confounded, it means we have infinitely many solutions. And if the 2 lines are parallel, it means there's no solution and the system is inconsistent system. First, we're going to see the first method of solving a system of linear equation, which is by graphing. So we have 2 equations and we need to solve by graphing. First, we're going to graph 2x minus y equals 6. So I took the intercepts. The y-intercept was 0, -6, and the x-intercept was 3, 0. Connect these 2 points, and this is a graph of 2x minus y equals 6. Now we're going to graph x plus 3y equal 10. So I took 2 random points, other the intercepts, plug the x coordinate in x plus 3y equal 10, and solve for y. Now where the 2 lines intersect, that's going to be the solution to my system, which is 4, 2. So the solution to that system is 4, 2. Although the solution to the system of equation appears to be 4, 2, you still need to check the answer by substituting x for 4 and y for 2 in the 2 equations. Upon substitution, we receive a true statement in both equations through the point 4, 2 checks. It is a solution to the system. Now we're going to take the same example and solve it by substitution. To solve by substitution, you need to write one of the variables in terms of the other. So I wrote x in terms of y. Now I'm going to substitute x in the first equation by the expression it represents. And I'm going to solve for y. Therefore, y equal 2. After solving for y equal 2, we're going to substitute y in any equation you want. But since x is written here in terms of y, we're going to substitute 2 in the second equation and solve for x. Therefore, the solution is the point with coordinates 4, 2. Now, we don't need to check because this is the same example we did before. We already checked before. But we solve it in a different way by substitution. Solving by addition or elimination. The goal here is to eliminate one variable and solve backward. We have a system, and notice we can multiply the first equation by -2 or 10 to eliminate one variable. So I decided to multiply the first equation by -2. Therefore, we're going to obtain -2x plus 2y equal 8 and 2x plus 10y equal 4 for the second equation. Add these two equations, the x will be eliminated, therefore we're going to get 12y equal 12. Solving for y equal 1. Now we need to solve for x. You can plug in 1 in any equation you want to solve for x. So I chose the first one. Therefore the solution is -3, 1 to my system. That's not enough, we still need to check. So yes, it is a solution after checking. And this is another verification by graphing. Now, sometimes when we solve a system of two equations with two unknowns, sometimes we get infinite solution or no solutions. So we're going to see the first example of no solution. So I decided to multiply the first equation by -2. Therefore, we're going to get -6x plus 8y equal to -24. We're going to add this equation to the second equation. Upon adding these two equations, we got 0 equal -7. That's a false statement. Therefore, it is no solution since we obtain a false statement. Now, we can manipulate this system to get infinity of solutions. We're going to change one number. And now, in this case, we have infinity of solutions. Notice when one equation is a scalar multiple of the other, it means the two lines are confounded. It means I have infinity of solutions. A system with three linear equations. Any equation in the form ax plus by plus cz equals d is a linear equation with three variables x, y, and z, and not all of them equal to 0. A system of three linear equations with three variables is something that looks like this. The graphs where the two planes intersect at one point, we have one solution independent system, or infinitely many solution dependent system, or no solution inconsistent system, where two planes intersect or the three planes are parallel. And keep in mind, when three planes intersect, they intersect at a line, or they can intersect at one point where we have one solution, or at a line where we have many solutions. The first example, we need to solve that system with three equations with three unknowns. To solve it, we need to pair equation in order to eliminate one variable. So I took the first one and the second one, and upon adding these two, the y variable got eliminated. Now you need to pair a different two equations to eliminate the same variable. So we need to eliminate the y. Upon adding the second and the third, we get another equation with variables x and z. So the y got eliminated. Now we're going to take the two equations that we have. We're going to add them to eliminate another variable. And in this case, the z will be eliminated and x equal 5. We're going to plug x in one of the above equations, but you can plug it in the second one if you want to solve for z. Solving for z equal -2. Now we're going to go back to the original system and plug x and y, x and z, and solve for y. So y equal 1. Therefore, the solution is a point with coordinates 5, 1, and -2. Now we need to check. We're going to plug instead of x, 5 instead of y, 1 instead of z, -2. Therefore, we have 5 minus 3 minus 6, and yes, -4 equal to -4. In the second one, we're going to have 10 plus 3 plus 2, that's 15 equal to 15. In the third one, we're going to have 20 minus 3, that's 17, plus 2, that's 19 equal 19, that's true. Therefore, the point obtained is a solution. Now we're going to see another example of three equations with three unknowns. Now to solve this one, we need to pair equations in order to eliminate one variable. So I took the second one, and then I multiplied the third one by 4. Therefore, the first one is 4x minus 4y minus 8z equal 2. And the second one is -4x plus 4y plus 8z equal -12. We're going to add these two equations, and we got 0 equal -10. 0 equal -10 is a false statement. Therefore, in this case, there's no solution. Another system. So we need to pair two equations in order to eliminate one variable. So I multiply the first one by 3 and added the result to the second equation. Therefore, the first one will become 3x minus 6y plus 3z equal 9, and the second one is -3x plus 6y minus 3z equal -9. Adding these two equations, we got 0 equals 0, and in this case, we have infinite solutions.